Hello everyone, welcome to my YouTube channel. I'm called Native Sarah. I'm going to discuss something small about my suggested project and as handwritten digit recognition. Although digitalization is being rapidly adopted in almost every sector, certain areas still require paperwork. And for sure, we cannot do without this. That's why we need a technology to make this process easier for computers so that they can recognize human writing on paper. So the main aim of this handwritten digit recognition system is to translate the written paperwork into computer-like format. I think this will really help us due to different challenges that we are facing in different offices. For example, I can just say our registration office, the registrar's office, they always make a lot of errors entering the information of students. But once we get this word recognition system, that will be able to translate this written paperwork into computer-like format, I believe these errors will be minimized. Also, to continue the data set that I've chosen for my project, I will use the means data set. According to my research, I believe it will give us some good work. The means data set is an acronym that stands for the Modified National Institute of Standards and Technology Data. The task of this dataset is mainly to clarify a given image of a handwritten digit into one of 10 classes representing integer values from 0 to 9 inclusively. I've also chosen this dataset because it's widely used and deeply understood for the most part. It is also the top performing model and deep learning convolutional neural networks that achieve a classification accuracy of above 99% with an error rate between 0.4% and 0.02. I mean 0.2% on the whole our test data. To know more about this neural network and deep learning, you can try to look for tutorials of machine learning, but here we shall not talk too details about it. But as we implement our project, we shall not avoid these terms. We shall keep on going on into them slowly. There are different factors that are considered for choosing the database that I've talked about before. Means dataset is one of the most useful datasets used for testing and comparisons. It also involves a bit of abstract thought that recognizes more as validation tool for vetting an algorithm rather than a product to sell in real life applications. Also means images are originally transformed into 20 by 20 pixels without any defined boundary. I believe when I speak about boundary, working about something without a defined boundary. It's very important to note that the features of the dataset that we are going to use, that is the means dataset, it contains 60,000 training cases in 10,000 test cases of handwritten digits. Each digit is normalized and centered in a grayscale of 0 to 255. That means data set is an evaluating machine learning model handwritten digit classification problem. So it's obvious that you have to use it. And I believe as we go on next time, we shall go into more details of that because that's what we are meant to really discuss in our data set. I also wanted to discuss something briefly about the Bayesian theorem. Bayesian theorem states that the conditional probability. Okay, I wanted to explain it in terms of probability because that's what it really stands for. States that the conditional probability of an event based on the occurrence of another event is equal to the likelihood of the second event given the first event multiplied by the probability of the first event. Bayes' theorem calculates the conditional probability of an event based on the values of specific related non-probabilities. Also, naive Bayes, it is a simple learning algorithm that utilizes Bayes' rule together with a strong assumption that the attributes are conditionally independent given the class. While this independence assumption is often violated in practice, naive Bayes nonetheless often delivers competitive classification accuracy. We also have something called a Bayesian networks. A Bayesian network is a probabilistic graphical model for representing knowledge about uncertain domain, where each node corresponds to a random variable and each edge represents the conditional probability of corresponding random. We also have the difference between Bayesian and naive. We have naive Bayes assumes conditional independency, whereas Bayes' theorem does not. This means the relationship between all input features are independent. We also have the difference between naive and Bayesian networks. Naive Bayes assumes conditional independence, whereas Bayesian networks allows the users to specify which attributes are in fact conditionally independent. According to what I've discussed, I also have different references here. My research was mainly made on Google. Thank you for your time, everyone. Thanks for listening to me. See you next time. As I told you before, we just introducing this, but we are going to dig deep and deep and deep into what I'm discussing about until we make a full project. Thank you. Wish you a nice time. Thank you.